Good morning, everyone. Welcome to October and welcome to our brand new seminar series, The Economics of Sustainability. My name is Eloise Ardley and I am the OUBEP Program Director. For those of you who are familiar with OUBEP, you know that we've been running this lecture now for since the start of the COVID crisis, which feels like a long time ago. And we wanted to really share the research happening in real time with the Department of Economics here in Oxford. So we started with the pandemic, but we wanted to expand to topics that you are all concerned with and that directly impact your business or your strategy. This time last year, we talked about the economics of discrimination before optimistically covering the economic recovery in the spring. This month, as we look towards COP26, we wanted to look at the fundamental issues of climate change. I would like to thank our sponsors, Micro and the NatWest Group, for making this event possible. And so we'll have 2 lectures and then 1 panel at the end of October. So I hope you can join us for all 3. If you'd like to better understand the link between economics and climate change, we have also been running a short bespoke course, which you can find more about on our website by clicking on the green button on the bottom of your screen. One more piece of housekeeping before we start. All participants are on mute, but please use the Q&A function to ask questions, and I will pass them on to Julian at the end of the session. So to kick us off today, we are delighted to welcome Professor Julian Allwood. He's a Professor of Engineering and the Environment at Cambridge University and Director of UK Fires, a research group on industrial resource efficiencies, whose recent Absolute Zero report has been making wave in the policy sphere. He's also the author of the 2012 book Sustainable Materials with Both Eyes Open. His research group investigates material demand reduction, novel material-saving manufacturing processes, and whole system analysis of energy, land, water, and material resource systems. So despite the old Oxford-Cambridge dispute, we are delighted to welcome Julian to OUBEP, which just shows that, what a brilliant and diverse community we bring together via economics. So over to you, Julian.
Thank you very much, Eloise. Can I just confirm that you can hear me and you can see the screen?
Absolutely. You're good to go.
Super. Thank you very much indeed for allowing me to join in as an engineer in the world of economics. Then obviously I feel a very tentative newcomer, although I try to run the most interdisciplinary group in Cambridge to try and address climate mitigation from all possible angles. We are currently in the second phony war of climate mitigation. The first phony war was the discussion of climate skepticism. We obviously had grown the Industrial Revolution assuming that energy was abundant and free of all negative consequences, and it took a long time for the scientists to communicate that there was a problem with that. To my taste, it ended in 2007 with the Nobel Prize-winning 4th IPCC assessment report. Perhaps more broadly, it ended with the Paris Agreement in 2015. And that's terrific. We had by then agreed that we had to do something. However, we are now in the second phony war, which has been going on ever since then, which is about techno-optimism. The framing here is that zero emissions is fundamentally a problem of economics. The solution is fundamentally one of innovation. So all we need to do is to get the incentives right, and clever people will come up with new technologies and they will profit from that, and we will then solve the problem. Largely without the consumers or voters having found out that anything changed. So that's the position that we're in at the moment, and it is a phony war. What is going to get us out of that, I think, is the growing evidence of catastrophe. This summer was particularly striking for that, and next summer will be more so, and so on. And the thing that's most positive at the moment in driving real change is the awareness that there is greater financial risk in this than people had previously recognized. Where we will eventually get to is reality. And that means that this isn't a question of economics, rather like the pandemic, it's a question of health and safety. And we will address that by living well, but within constraints, living differently, but well within constraints. And I think there's no doubt that that will involve living in a changed climate. Probably we will be unable to act before there has been at least one episode of mass death from resource shortage. So I hope there will be chastened people living well in a changed climate. What I'm interested in is how we get out of phony war 2, and that's what I want to talk about today. Here is a bit of evidence about phony war number 2. You can see these well-known, high-profile, high-emitting companies are all absolutely confident in their proclamations that they have a plan for getting to net zero carbon emissions by 2050. Just to take a slight clarity on that, that means in 28 years' time from now, or it's the time by which the people currently at university are likely to have reached their major management roles. So British Airways are going to solve it with offsetting biomass and hydrogen. Shell are going to do capture and storage and offsetting, and ArcelorMittal are going to do hydrogen, bioenergy, carbon capture, use and storage. So that's all very optimistic. The new technologies will solve the problem. Here is the allegedly independent advisory body, the Climate Change Committee, that advises the UK on the policy trajectory towards zero emissions. And you can see the chart, the so-called balanced pathway, has here a small component of demand reduction and what they call efficiency, which is never really specified, which as an engineer is slightly worrying, that we'd like to know quite what efficiency they're talking about. And absolutely everything else is about new technology deployment, either electrifying the energy supply, of course that's not necessarily new, and electrifying demand, and then everything else, hydrogen, carbon capture and storage, and negative emissions are new technologies. If I summarize the resource requirements of the Climate Change Committee's current plan, then remember that hydrogen is not naturally occurring, and there are only 2 ways that you could create it without emissions, either by electrolysis powered by non-emitting electricity, or by splitting methane, as it's done at the moment, but linking it to carbon capture and storage. And equally, negative emissions technologies don't exist. The only options are either to power something with non-emitting electricity or to grow trees. It's worth commenting at this stage that in the UK at the moment, there is no zero emissions hydrogen production whatsoever. And to give a sense of scale to the biomass, then if we doubled the area of forestry in the UK, then over a period of about 60 years, we would capture 2 years worth of current emissions. Trees grow very slowly and they don't absorb a very large amount of carbon from the atmosphere. So the clear message here is technology will solve the problem, and those are the resources that we're going to require. Lastly, in my survey of UK politics, here is the UK government's 10-point plan announced at the end of 2020, and you can see some very familiar candidates here. I've reorganized them to show that the plan is essentially the same. Non-emitting electricity, negative emissions and biomass are the 3 key resources, with a little bit of efficiency or service substitution. I have learnt that while living in Cambridge, possibly the flattest area of the UK, that it's not safe to mention cycling and walking in a public talk, because everybody else by definition lives in a place that is hillier, and you sound an ignorant, privileged person in an ivory tower as soon as you talk about cycling. However, maybe there are some other substitutions there. So the starting point for what I want to cover is that there is currently the second phony war is in full flight at the moment, based on the concept that new technologies are going to solve the problem. And I want to ask 4 questions about this. Is offsetting compatible with net zero targets for 2050? Do the plans add up? Is there time to bring them about? And are we really taking a balanced view of risk in the way that we are addressing this issue at the moment? So let's start with offsetting. Offsetting has been around as a discussion point for about 20 years. And I would say it had largely lost all credibility over the last decade, until the influence of Mark Carney and Bill Gates has brought it very much back into the fore of discussions under the cozy phrase voluntary carbon markets. Well, let's just think about the timeline of an offset. If you cause a release of emissions, let's say you do it by buying a fossil aeroplane ticket and fly across the Atlantic, then that causes an immediate release of emissions. You feel guilty about that, so you pay for an offset. And there will always be some kind of delay from when you paid to when the offset begins to happen. Then in many cases, the offset will initially require additional emissions with some form of capital investment, or in the case of afforestation, with releasing organic soil carbon as part of the planting process. So most offsets include some kind of release. Then the offset begins to bite, and over some period, over some lifespan, removes emissions, removes carbon dioxide and the other greenhouse gases from the atmosphere at some rate. So that's a rather simplified model of an offset. And now let's think what would happen if I tried to run an offsetting scheme that would work to cancel out the effect of one economy class return flight to America. In economics, you probably aren't aware of that, but behind you, when you get onto an aeroplane, there's a whole load of poor people sitting in much smaller seats that you won't have seen. So an economy class ticket per year flying from London to New York. And what I want to do is to design an offsetting scheme using this model that will be sufficient to ensure that by 2050, the target date for net zero, the atmospheric stock of emissions is no greater than it was before you started taking the flights. It seems to me that that's the only meaningful definition of offsetting. Now we have a target for net zero in 2050. Well, this graph shows for 3 representative offsetting schemes using real data that the scale and cost at which an offset would have to operate is far greater than anything being offered today. So currently buying that aeroplane ticket would be very cheap. It's about £320 because demand is so low at the moment. And you can buy an offset for around about £30 to £40. Let's call it an offset. You can buy something which deals with your conscience for that amount of time. But what I've done here is to show the scale at which you would really have to deploy an offset if you wanted to guarantee that we'd got to net zero, the effect of your activity didn't increase atmospheric stocks. And what you can see is that the price is very much higher than any offset being offered today. The cost or the price grows very rapidly, more than exponentially. This is a log scale y-axis here. As I approach 2050, to the point that there is no offset available. And obviously that's, if there's a delay before the offset is implemented, then sometime before 2050, we know offsetting is going to be impossible. But if the offset implies some capital emissions, and I need to make sure there really is no net addition to atmospheric stocks, the scale at which I have to apply it grows and grows as I approach 2050. The other thing on the graph is that eventually I've exhausted all the capacity. So the green line turns into a dashed line at the point that I've replaced every car on the planet by an electric car, or in this case, where I've replaced all blast furnaces by direct reduced iron furnaces. So I'm afraid the story with offsetting is that it's almost entirely a hoax. It's just possible that you could buy an offset over the next few years, but it would be vastly more expensive than any that are on the market. And I think it's worth thinking here that I've given 3 representative examples. If I gave every possible offsetting mechanism and plotted it on my graph here, then around the lower right half of the curve, you could imagine drawing some kind of envelope curve. And that then is, in fact, what the cost of carbon or the carbon price would have to be if we had a globally meaningful carbon price predicated on getting to net zero by the year 2050. Obviously, the price is used in order to release some form of physical action that will reduce emissions. So if I plot all the physical actions on here, you can see I would then get the envelope curve. As we approach 2050, the carbon price has to be infinite. And I think that's an argument for saying, well, maybe the carbon price is no longer the right fundamental mechanism for directing policy. It was relevant when we wanted less emissions, but now we want zero emissions. It's not necessarily the right mechanism. So offsetting just about possible for another 5 to 10 years. But to be honest, given the cost, it would be far better if the people able to pay that cost use the money to invest in alternatives to the redundant fossil emitting practices of the past. Let's just look at the total requirement for the resources. I've made the point that the political rhetoric of the UK is essentially drawing on three resources: non-emitting electricity, that's renewables or nuclear; negative emissions, that's typically called carbon capture and storage, or potentially direct air capture; and biomass. At the moment, there are no negative emissions technologies operating in the UK. We are expanding our non-emitting electricity at a roughly constant rate since about 2010, to the point that it's now equal to about half of our supply. So over the next 2 decades, if we keep going at that rate, we'll roughly end up with a zero emissions electrical supply equal to what we have today. But note that we'll actually be wanting quite a lot more, because by then we will also have electrified all our transport and heating. So the graph on the right shows the requirements that the Climate Change Committee is anticipating we will need by 2050. So the x-axis is 100% of what we need in 2050. And then the green bars show where we are at the moment. So you can see that the Climate Change Committee is anticipating that we will grow our non-emitting electricity by a factor of 4. That's nearly possible. I think we would guess that you could grow it by a factor of about 3 at the rate that we're currently going. Our biomass supply is to go up, which looks modest, except that when you look at every conservationist in the world talking about biomass, they all say that we're already harvesting too much to create so much danger for other species, and biodiversity depends on us reducing our total draw for biomass. And the negative emissions one is truly shocking, that we have none at the moment, and this is, as you can see, more than a quarter of the government's plan for getting to net zero is a technology which doesn't exist at any operative scale whatsoever in the UK. It does exist in the world. 0.1%, or the total capacity of the world's carbon capture and storage is 0.1% of current annual emissions. We don't know how much of that capacity is actually in use, but we do know that 3/4 of it is used, ironically, to get more oil out of the ground. So it's a very tall order indeed to imagine that we're going to scale that to the level required. You could, I think, fairly comfortably say it's pretty unlikely that we're going to develop this plan. Let's now think about the rate at which we could bring these things about. Here's a timeline of the Hinkley Point C project. The yellow bars show the International Atomic Energy Authority's project guidelines for building a new nuclear power station. And the purple shows what's happened to date, with the light purple being where we've got to now. So roughly 22 years if we stay on schedule now, but that's probably pretty unlikely to bring about one new nuclear power station. And we know that. So that means that by the next election, but certainly by the end of this decade, we will know for sure how many nuclear power stations will be operating in the UK by 2050, because the projects take a long time. It's not just construction, it's also about public negotiation, land rights, discussions on public finance and so on. The whole project takes a very long time. Well, you might say, at least we can build wind turbines pretty rapidly. You just rattle them off a production line. And here's the timeline of the current biggest wind farm just about to come on stream in the UK, the Hornsea 2 project in the North Sea. Deloitte's project lifespan for a new large wind farm offshore is about 14 years. And here we're doing pretty well. It looks like we'll finish in 16 years. So what that says is that it actually takes a long time to do this. To install one of these projects takes a long time. And there is therefore a limit to the rate at which we're going to ramp it up, because all of these projects require government participation. They imply risk, and there is a limit to political appetite for risk in taking on these large projects, particularly obviously with nuclear. And you can say very much with carbon capture and storage. If we currently don't even have a kilogram being captured and stored in the UK, then obviously we need a pilot plant without any question. Once that's been proved, then the government will maybe have confidence to do one at scale, but they're not going to do 5 at scale until the first one at scale has operated. So it's very unlikely we're going to have any significant carbon capture and storage just because there isn't time left to build it. We've done a big study on that, looking at the rates of deployment of new electricity technologies in the countries that deployed them fastest. And what the graph shows is that before the first commercial installation, which is at the origin of this axis, there's a period of between 30 to 100 years of development as the technology is invented, tested, scaled up, and eventually we get the first commercial demonstrator. But then there is a delay. Now, in French nuclear, which is the fastest deployment rate, a lot of this did occur over a 10-year period, but only 30 years after the first commercial installation had occurred. So it takes a long time to deploy new energy technologies. As a result of that, if we're being rational about thinking, developing climate policy, what we should be doing is to divide technologies into 2 buckets. There are new things where we want to gain experience, and that is absolutely everything available. We want to try everything to increase our armory of options, whether that's hydrogen, carbon capture and storage, negative emissions technologies, electric planes, absolutely everything. But what we should be focusing our policy on is deploying things that have actually operated at scale. If you think about the UK's trajectory so far, new technology has played no part whatsoever in the UK's mitigation to date. The 3 things that have been really big are Mrs. Thatcher's fight with the unions leading to the switch from coal to gas power, Mrs. Thatcher's decision not to support UK heavy industry, so we then import our emissions rather than emit them ourselves, and wind power and the EU legislation on landfill tax leading to us capturing more methane at landfill sites. Wind power scaled in the early 1970s in Denmark. It is not in any way a new technology. So the key is that we should be separating new technologies that we want to gain experience of from familiar technologies that we know we can deploy at scale. And just incidentally, we can change public behavior much faster than we can deploy new technologies. That's the bottom part of the graph. And we all know that because last year we changed our behavior very radically once we recognized that there was a public health and safety threat. So finally, my 4th question about techno-optimism is about risk. The graph on the left here is the first result of a PhD student that has been working with me for the last 3 years on societal collapse. We're worried that the phrase global warming sounds too nice, particularly in the UK, and particularly right now as it's just got so cold in October. But that's a very cuddly phrase, and what global warming really is about is food shortage and uncontrollable migration, particularly from the equator northwards. So what my student has been doing is taking the IPCC's current projections of rainfall temperature and to run them through the United Nations FAO model on crop productivity to look at the rate at which food can be grown in different countries around the world. And her provisional results, which she just showed me this week, and I really hope these are wrong, here is the population today going into the future. And you can see the first dramatic collapse of population in Africa she's predicting within the next decade, which I find terrifying. But look over here in Oceania, in the 2040s, she's seeing a loss of about half the population due to starvation. Well, this is pre-publication. We've got a lot of work to do. I really hope that she's got the results wrong, but the form of that graph is right. That's actually what we're talking about when we talk about climate change mitigation. And I think we haven't got that. I regret the fact that the Stern report introduced the idea that climate mitigation, the cost of it was a % of GDP, because it sounds as if there's therefore the option of not spending a percentage of GDP. But not spending it, not acting, means the end of GDP. And we haven't got that sense of jeopardy into our rhetoric about climate mitigation so far. But also on the right-hand side, this is conceptual, there's no data behind this graph. You can see that the highly techno-optimistic focus of today's rhetoric is very high technological risk. And the reason it's there is that it would be politically and commercially attractive if nobody noticed the solution. The opposite of that is, if you like, virtuous asceticism, when we all voluntarily choose to modify our behavior. Because I'm an optimistic human being, I still believe that's possible, but my friends in economics tell me that's naivety on my part. But in the middle here is what I've called the missing obvious. We cannot allow politics to polarize the options for mitigation into the binary option of technology or behavior change, because in the middle is using familiar technologies differently. And the fact that the cars that we drive on the roads of the UK are 12.5 times heavier than the people in them means that almost all oil use in the UK is to move metal around rather than to move people. It's absolutely crazy, and nobody is bringing that to the fore of the policy discussion. So the conclusion is rather obvious from this, that the phony war number 2, the techno-optimistic view of climate mitigation is doomed. There is, well, let me try and be quantitative about that. It's 99.999% certain that the techno-optimistic rhetoric will fail. There aren't any meaningful offsets, or they'll disappear very soon. The plans, when they add up, look like they have an impossible demand for the 3 fundamental zero emissions resources of non-emitting electricity, biomass, and negative emissions technologies. The rate at which technology can be introduced is too slow, and we can't get round that. And we're not taking a real view of the risk of failure, and therefore activating the rest of the solutions that would become prominent if we stopped believing that magic beans fertilized by unicorns' blood, carbon capture and storage will emerge at scale to take the problem away in 28 years' time. So what does real look like? Well, on the left is a pie chart of all of the things that cause emissions in the world at the moment. You can see on the top right are engines that burn fossil fuel in vehicles. The bottom right is engines or turbines that burn fossil fuels to make electricity. The bottom left are burners and processes in industry that essentially make the bulk materials. Steel, cement, paper, plastic, aluminium are the dominant, and fertilizer are the dominant outputs of that sector. And at the top left are the natural processes of deforestation, agriculture, and waste decomposition. So the law of the UK, the 70% of the world's GDP that has signed up to have net zero by 2050 is saying that we're going to close all of these in the next 28 years' time. And I still believe that's possible, but we haven't started taking any of the right actions yet. If I translate that into forms of action that individuals can take, then at home, there are 4 big actions. Swap the fossil car for an electric car, swap the fossil boiler for an electric heat pump, stop using fossil planes, and stop eating beef, lamb, and dairy. Those are the ruminants over here, which are very specific. Pork and chicken are not in that list. It's specifically beef, lamb, and dairy. The materials production, the industrial emissions, are hardly touched by people's behavior at home because they're mainly about the bulk materials, and the decisions about bulk materials are mainly taken by people at work. So what matters at work is fundamentally that we switch from building new buildings to adapting the buildings that we already have. We need to move to an all-electric system of bulk material provision and obviously swap out any other fossil fuel use. And you can see that there are some obvious asks to government here, expanding the non-emitting supply, electrifying infrastructure, and so on. And in due course, we have to regulate. That is the policy mechanism required to bring about the scale of change at the speed that we need it. We tried to give this reality for the first time at the end of 2020, when we published, the end of 2019, just before the end of 2019, we published Absolute Zero, which was the first report that tried to describe a realistic path to zero emissions based on today's technologies. I'm not sure if I can access the chat at the moment, but I have 2 documents I'd like to share with you This is the first one, so maybe the organisers will be able to give me access to the chat to share those with you during the Q&A session. Here is the history of electricity production in the UK over the last 2 decades. You can see that in the 2010s, we expanded at a linear rate. So let's just assume that we're going to keep going at that rate. That's roughly right. We're not actually on track for that at the moment. The government committed to quadrupling offshore wind by 2030. We're not actually, haven't signed the contracts to get there yet. And Hinkley Point will, of course, come on stream, but by 2030, every other nuclear power station in the UK will have shut. So we're not quite on the same trajectory that we were on the past decade. But if we're optimistic, you can see that that would get us to this amount of electricity. I'm deliberately not using numbers in the talk. If we electrified everything that we do, then we would need to the top of the blue line of electricity, and that's ignoring the imported goods following Mrs. Thatcher's policy that if it's happening in a foreign country, it's nothing to do with us. And you can see that we will have around about 60% of the electricity we'd like to have, having electrified everything we do. We showed in the report that we could live very well with 60% of the electricity, for example, with smaller cars and better insulated houses. But there are 4 activities that for which we have no substitutes. So those are eating lamb and beef and dairy products, shipping, flying, and cement. And as we stand, there are no options for those. I should be slightly specific about that with flying. There are the whole army of people lobbying to tell you that zero emissions flying is going to come. And that's because of so-called, you could fly planes on hydrogen or synthetic fuels, on biokerosene, on batteries, and so on. None of those options aggregate that we won't have a sufficient supply of biomass or negative emissions, non-emitting technology, non-emitting electricity to be able to get there. So the absolute zero message was to say all energy will be non-emitting electricity. We can't expand the total human use of biomass, and there won't be any negative emissions technologies. So let's stop saying net zero. What we actually mean is absolute zero. That's what the law is committing us to, and what all the countries around the world signing up to so-called net zero targets are actually saying is they're committed to absolute zero emissions in 2050. If I compare that with the current policies of the UK government, then you can see that the key difference for us is that we've removed the negative emissions and biomass activities or resources because we won't have any available at any meaningful scale. So instead of those, we need much more efficiency, substitution, and in due course restraint. There will be no flying with zero emissions. But efficiency is probably worth unpacking. It won't surprise you to know that the Formula One high-emitting car racing competition is nothing other than a competition to make an efficient engine. So we know how to make very efficient devices that convert energy into work or heat. That's not where the inefficiency is. The inefficiency is in the thing that we're then powering, the large car, the leaky house, and so on. So the inefficiencies are about the way that we take service from energy rather than the conversion of energy into work. There are lots more opportunities for substitution that we haven't even started thinking about. And the restraint is nowhere near as bad as the people who want to polarize the description of either technology change or behavior change would have us believe. Let me now talk about what might bring that about. And I'm going to end this with the financial mechanism of ZERPAs, which is the title of this talk. In the next 28 years, these sectors must all close, and they're therefore all currently overvalued. Fossil fuel supply and distribution. Incredibly, the big 6 energy oil companies spent, according to Goldman Sachs, last year they spent an average of 5% of their capex on renewables. And yet all of their products are illegal within 28 years' time. They're simply not facing reality there, and the investors who are valuing them haven't got it yet. All cement and blast furnace steel production, all of today's sites must close, and therefore, in effect, all new construction is going to have to stop. We won't have any cement. Beef, lamb and dairy farming has to stop. Fossil-powered aviation and shipping and all of the infrastructure around them has to stop. With shipping, it is possible that we could come up with electric ships because they've got the volume to be able to take the massive batteries. There are a few crossing the Norwegian fjords. There are a few battery-powered electric ships, but we haven't yet started any serious plans about trying to bring them about, and we've only got 28 years left. And obviously, fuel combustion equipment and so on has to go. So Rolls-Royce, for example, all of its products at the moment are illegal. It's making noise about trying to develop small and medium-sized nuclear reactors. That would be great, but they haven't been tested. We don't know whether the public want to live in a city with a small nuclear reactor right next door to them. So we can't, as yet, make any prediction about that market growing. So that's reality. That is what the law says. It's not my opinion. That's the law of the UK telling you that all of those sectors must close. As a result, it's obvious that a set of other sectors must grow in compensation. Obviously, anything to do with non-emitting electricity supply and distribution. Electric material production, we know that the supply of scrap steel available for recycling is going to treble in the next 20 to 30 years, because on average steel lasts in service for 35 years. We know what was made in the past, so we know it's going to come back. And there is a huge market for growth in electric steel production. For example, we could make plastics and chemicals using electrical routes, but we don't at the moment because they're so intimately linked to cracking oil for petrol production. There is a big opportunity for electric plastic and chemicals industries. Plant-based diets are obviously going to grow, and so on, electric equipment. So that's just by substitution. But actually, there's a whole series of other sectors that are going to grow, which we're now trying to draw attention to. And so, for example, at the moment, information provision about responsibility for emissions is at a premium because it's difficult, and there are so few, if any, trusted providers in that area. I moved to an older house a couple of years ago. My youngest son just went to university, so I'm in the empty nest with the prospect of having savings for the first time in my life, and would like to retrofit this house, and I cannot find the advisor to come and help me build a plan for how I get this to passive standard over the next 10 years. There's a demand for new advice, new consultancy, and so on. We're going to be short of energy, therefore there will be a whole set of new sectors that deal with both energy demand reduction and indeed coping with temporary energy shortages, which is going to become a regular feature of our life. In the absence of shipping, we know that domestic manufacturing is going to grow. There'll be new opportunities in the UK. We know that the payback periods of some of the things we have to invest in, like retrofit, are long. So that's going to require new financial mechanisms, as is government policy in the area. And we're going to have much less materials available. So there'll be new design and manufacturing and maintenance systems associated with using materials in a more efficient way. Overall, we have no idea what the total effect of that on the economy is. We know that on the left, those sectors have to shut, and one view of that is, oh dear, that means the economy is going to shrink. But I honestly don't think we can say that. We just don't know the size of the activities that are going to grow in compensation. The critical thing is that we start drawing attention to the right-hand half of the screen to accelerate progress in those areas. If we are to be real, then these are the forms of policy that matter, that are urgently required. I think the top one is probably on its way soon, an end date for the sale of all gas boilers, both domestic and industrial in the UK. I hope that comes soon, rather like the electric car regulation. I like this second one, to transform stamp duty and combine it with new forms of energy bond to guarantee deep energy retrofits as houses change hands. That's the moment when it's possible to get in and do a really big 3-week project on retrofit. And if it was linked to stamp duty, that might be rather an efficient mechanism. Only a third of the rail network of the UK is electrified at the moment, so we've got 28 years to electrify the rest, and we'd actually like to be expanding it. And in the absence of any meaningful options for HGVs, what we need is overhead cables on motorways so that HGVs can run with a catenary and then use battery power only for the last 5 miles of the journey, and so on. So these are the real policy options we need after we come out of the second phony war. And lastly, really what I advertise the title of this is to say, what can the finance sector do about this, given that as we stand, the finance sector looks like it's taking one of the more active stances in trying to bring about change. Let's think about the airlines. The rhetoric I put up, the very first thing I showed you in the talk was the rhetoric of British Airways. So here is last year's balance sheet of the owner of British Airways, IAG. I've just shown the assets. And the question is, looking at that asset list, do you as an investor know that British Airways are going to deliver on their plan? So to remind you, what they said is that they have a clear trajectory to achieving net zero in 2050 by a combination of offsetting carbon emissions, sustainable aviation fuel from biomass, and hydrogen. So the balance sheet does not confirm for me that any of that is real, and therefore I should be writing down the long-term prospects of the company. But what if it looked like this? IAG buys approximately 10 million tons of aviation fuel per year. And if I've done my sums correctly, that requires the harvest of about 500,000 hectares of arable land and about 100 gigawatts of wind turbines. So at current prices, that roughly requires the investment that I put on the balance sheet there. You can see it's made a significant difference to the total assets of IAG. But were the company showing me a plan like this, then I could say, okay, I believe that your rhetoric is backed up by your balance sheet. I can safely leave my money with you. You'll be prospering in 2050. Well, it's pretty unlikely that IAG are in fact going to become biomass farmers or wind turbine operators. So instead of them owning it, what we need to find is a mechanism whereby they can show on their balance sheet that they have secured access to these resources in the future. And it doesn't necessarily need to have the full resource now. What matters is that they can show that they have access to the resource in future. So what we want to add to their balance sheet is some form of procurement agreement which looks ahead and guarantees that they will be able to access the zero emissions resources they need in order to deliver their rhetoric. That would then take the risk out of staying invested in them. And that's our proposal. So again, at the end of the talk, I will share with you this document, the ZERPA proposal. ZERPAs are zero emissions resource procurement agreements. And the intention is to allow corporates to secure their future access to the resources, to allow investors to confirm that the zero emissions plan is real, and therefore to stimulate the supply of those zero emissions resources through improved financing. So they'll reveal the likelihood of the constraints that I've been pointing to, the fact that the aggregation doesn't work at the moment, and they'll lend credibility to pledges and support the growth of zero emissions production. The concept of our ZERPA proposal is that it builds on the existing contracts for differences that have been used to stimulate the supply of non-emitting electricity in the UK and elsewhere. So we're going to expand them to cover also biomass and negative emissions. This is our proposal. And the contracts will be available over a longer time horizon. So they could be operating from now up to 2050. But in the contract for difference, the government remains the counterparty to the contract. And our proposal is that we have a secondary market in which the government then sells these contract for differences onto users. So in the primary market, the supplier of resources bid with a strike price to guarantee their revenue, to allow them to secure investment in expanding the capacity of non-emitting electricity, biomass, or negative emissions technologies. The strike price will give them the security to do that, but the government can then sell on those contracts to users such as IAG, who by placing the contract on their balance sheet are then able to show that they have got a meaningful commitment to delivering on their plan. So this is how we anticipate the ZERPA's markets might operate. It depends on having the government probably, or some other trustable body acting as an intermediary that certifies the contracts being offered. So the producer of zero emissions resources would bid for these certificates in an auction and then be issued a contract by the intermediary. That would be sold to a user, somebody whose corporate plan depends on it, and could then be traded. So if the user's anticipated demand changed, or if they went bust, they could trade it in a secondary market, which would obviously have to be relatively liquid to allow this to work. And then the producer could either expand their supply at least to deliver on what they've committed to in ZERPAs, or to have a sufficient extra supply that they can also sell on a spot market. So users are then able to de-risk the future price because they've got the ZERPA price committed from the certificate that they've purchased, or if they find they have insufficient, then they would buy the top-up on the spot market. So as economists, you can all interpret that, I think, much more effectively than I can. But the mechanism, you can see, is a fairly simple extension to what's been going on with the contracts for difference. There's a question about whether ZERPAs should be physically settled or financially settled. On the electricity grid, it's difficult to know, you can't tell what type of electricity you're buying when you, as a user, plug into the grid. So in effect, they have to have a financial settlement to confirm that what you've paid for is indeed non-emitting electricity. But potentially with biomass and with negative emissions technology, there could be a physical settlement. So there's a one-to-one connection between your ZERPA certificate and the physical resource that you access in the future. So our proposal, and we're trying to put this out to, if you like, socialize it, to get people to start talking about it and discussing it, is that ZERPAs would price resource constraints. They would expand support for investment in new capacity, allow users to secure future access, allow policymakers to anticipate national constraints and stimulate a wider basket of policy options, and allow regulators to reveal constraints and thereby improve financial stability. So to wrap up, my talk has been about the fact that we are in the second phony war of climate mitigation. It will end. There will come a moment when public concern is so dramatic that they then turn on the government and say, why on earth didn't you act for real sooner? It may be that's beginning with the youth protests going on at the moment. It will occur for serious, more so when the finance sector realizes that this isn't a game of trying to trade off mitigation against other profitable opportunities, that it's about survival. We know that we can live well within the real constraints of zero emissions. But the really important point here is that there is a huge space for new business growth in sectors that we haven't really anticipated yet, because the techno-optimistic rhetoric has pointed us only towards magic beans. But as we stand, investors, as one of the people we talked to told us, can't distinguish the wheat from the chaff in corporate plans. The ones I started with are, I'm afraid, close to chaff. But there could be a meaningful corporate plan if it was backed by access to the zero emissions resources. And the ZERPA mechanism, we think, could be a useful way of aiding that negotiation between suppliers and users. So thanks very much for listening. I'm really looking forward to the discussion.